Hi, Chem12. So what we're going to look at today is a continuation from Monday. So Monday we talked about balancing half reactions. And now what we're going to do is we're going to start to balance full redox reactions. Okay, and so there's going to be two approaches. The first one we're going to look at it is a continuation from Monday where we're going to use the reaction method. And then the second one we'll look at is a different method using oxidation numbers. So with the half reaction method, what you do is you balance the two half reactions individually, and then just like we did on Monday. And then what you want to do is you want to make sure that electrons lost equal the electrons gained. Okay, and that's going to require multiplication. Okay, so I'll show you how to do that. And then finally, you add the two half reactions after you do that multiplication. So let's look at this one here. Okay, so you've got, this is a full redox that's unbalanced. And so again, it tells you what type of solution it is. It's an acidic. So what you have to do first is you have to figure out which of the reactants goes with the products. Okay, and so one half reaction is going to involve the phosphorus. Okay, so it'll be those two. And then the other one will involve the iodine. Okay, so let's look at the phosphorus first. Okay, so what you have here is you have 4 phosphorus. So remember the method, we have to balance major atoms first. So we multiply this one by 4, so the phosphorus is 4 on this side. And then you look at the oxygen. You have 16 here, so then you add water. So we add 16 waters to get the oxygen. And then you have 32 hydrogens here, 8 hydrogens here, so we have to add 24 H pluses. Okay? And then after we do that, then we balance the charge, and so we do that by adding 20 electrons because we got negative, we have negative 4 here, positive 24, so that's positive 20, and so plus negative 20 is 0, so 0 on this side, 0 on that side. Okay, and then the next one, same thing. We've got the iodine. I's are already balanced. We have 3 oxygens on this side, so we have to add 3 waters. We have 6 hydrogens, so we add 6 H pluses. This side's minus 1, and so we add 6 electrons here to counter the 6 positives, and then we have minus 1 over here. Okay, so what you have now is you focus in on the electrons. You got 20 electrons there, and you got 6 here. And so this is sort of like getting a common denominator with fractions. You want to multiply so that you get electrons gained equal electrons lost. So the common multiple here is going to be 60, right? So you multiply this one by 3, and then you multiply this one by 10. Okay, so we're going to multiply those, and then what we're going to do is we're going to add them. Okay, and so after we add them, then just like any other math equation, if we have the same things on both sides, we can put it in simplest, we can start canceling things out. Okay, so we multiply. Okay, so that's what we get after multiplication. Okay, so this one by 3, this one by 10. And now we add the 2 up. And so this is what you get. Okay, so you had 48 waters here, you had 30 waters here, so these will cancel out, and this will change to 18, which is what you have here. And then you've got 72 hydrogens here, and you have 60 here, so this will go away, and you'll be left with 12 over here, right, which is the 12 here. And so again, notice you have 60 electrons here and 60 electrons here, so that goes away as well. So the remaining is the 18 waters, 3 phosphorus, 3 P4, sorry, and then the 10 IO3 minuses, and then on this side the 12 H2PO4 minuses, and the 12 hydrogen pluses, and then 10 I minus. So just like you always do with balancing equations, now what you can do is you can go through all the atoms, left side, right side, make sure you have the same number, and then also look at the overall charge, right? So the overall charge on the left here is negative 10. Here you've got negative 12, positive 12, negative 10, right? So it adds up to negative 10, and then you can go through all the atoms. Okay, let's look at a couple more examples. this time in basic conditions. Okay, so same as before. Okay, so we've got the two manganese, right? So this one's going to go with this one, and then the sulfurs will be the other half reaction. So major atom, Mn and Mn are both 1. We've got 2 more oxygens on this side, so we add 2 waters, 4 H pluses. So we add the 4 H pluses, and then we add 3 electrons over here, so that we get 0 on this side because there's 0 on this side. Okay, so this is where we would leave it if it's acidic. It says basic, so we want to get rid of the 4 H pluses, so we add 4 OHs on both sides. Okay, and so these 4 here will turn into 4 water. Okay, and you've got the 2 waters on this side, right? So what's going to happen here is the 2 waters will go away, and then this will become 2 waters over here. Okay, so this is why you get 3 electrons, 2 waters, MnO4 minus, MnO2, and the 4 OHs. Okay, next one with the sulfurs, same thing. S is already balanced. We've got 1 more oxygen on this side, so we add water. We got 2 hydrogens, so we add 2H plus, and then this side's the -2. We've got -2 and positive, that's 0, so we add the -2 here. Get rid of the H plus, add 2 OH to both sides. Again, this is going to form 2 waters. Okay, you've got 1 water on that side, that'll go away, and then this will be 1 water. Okay, and so we've got SO3, 2 OHs, SO4, 2 minus, the 1 water, and the 2 electrons. Okay, so we've got 3 electrons over here, and we've got 2 electrons over here. So we're going to multiply this one by 2 and this one by 3, right? So you get 6, and then we add them up. Okay, so we're going to get, so this is after you multiply by 2. You've got 2 times here's 4 waters, 2 MnO4 minus, and then you've got the 3, we multiply this by 3 SO3 2 minus, and 6 OH minuses, and then we've got the 2 MnO2s, 8 OH minuses, and the 3 SO4 2 minuses, and the 3 waters. And so now what you can do is you can cancel out, get rid of these 3 waters, and then that leaves 1 water left over here. And then you can get rid of the 6 OHs, that leaves you 2 OHs over here. Okay, so this is the reaction here. Okay, so this is the balanced reaction. Okay, let's do one more. This one, the last one here, this is a kind of a weird one because you've only got the 1 reactant and you've got these 2 products. Okay, so again, it tells you it's basic solution. So how do you do this? So you're going to have 2 half reactions. The Br2 is going to be involved in both of these. Okay, so the first one here is going to be Br2 going to 2Br, going to Br, so you just multiply the major atoms, you multiply this by 2. There are no oxygen or hydrogen, so you don't have to worry about water or H+. And so -2 on this side, so we simply add 2 electrons. The next one, we've got Br2 going to BrO3 minus, so multiply by 2 to get the major atoms balanced. We've got 6 oxygens, so we add 6 waters. We have 12 hydrogens, so you add the 12 H pluses, and then you add 10 electrons to get the charge to be 0 on this side like it is on that side. Okay, and then we add 12 hydroxides to both sides because it's basic. So again, this will form 12 waters, and you've got 6 waters here that'll go away, and then this will become 6. Okay, and so here you are, Br2, 12 OH minus, and we've got 2 BrO3 minus plus the 6 waters and the 10 electrons. So this is 10 electrons. That's 2 electrons. So all we have to do is multiply the first reaction by 5. Okay, and so we multiply that by 5. So that's going to give us 5 Br2, and then plus the other Br2 and the 12 hydroxides. And then we multiply this by 5, so that gives us 10 Br minus plus the 2 BrO3 and the 6 waters. And so you can put these two Br2s together, which will give you 6. And then again, there's your reaction. Okay, so you have minus 12 on this side, minus 10, minus 2, so minus 12. And then again, you can go through all the atoms and make sure that you have the same number. Okay, so what I'll get you to do is page 207. Number 24. Okay, so that's simply exactly what we're looking at here. You're just balancing full redox reactions. So you got to split it into the half reactions, balance the half reactions as we did on Monday, and then ensure the electrons are gained equal to the electrons lost by multiplying the individual half reactions, add them up, and then cancel any things that appear on both sides. Okay, and again, you should be able to check your final answer to see if it's reasonable. Okay, and go through that. Let me know if there's any questions that you don't understand, and I'll help you with that before for Friday's lesson. Okay, so try to get that done for Friday. Okay, and just again, keep asking questions so that I can go through stuff that you're struggling with. Okay, so stay safe. I'll talk to you again on Friday. Okay, bye now.